So, first question, has anybody in this room ever heard of the Ballerina language before this moment? Show of hands, no hands whatsoever. To be expected. This is a relatively new entrant in the whole world of the programming language space. And so the intent for this particular talk is to explain a little bit of the why behind Ballerina and do enough to get you started. So I'm not going to do all of the ins and outs. This is not going to be a comprehensive overview of the language. As a matter of fact, it's going to be more code focused than anything else, showing off various things, exploring what we see. Just as a heads up, we are not going to go through all the slides because the slides are intended a little bit more as a takeaway artifact to go back and look at things later, as something to help you get started with Ballerina down the road. What I want to do essentially is introduce you to some of the interesting concepts that Ballerina has, specifically the idea of what would it look like if we created a programming language that was service-oriented by nature. Ballerina is not an object-oriented language. It does have some concept of objects, but it does not feel beholden to try to do everything that Java or C# ever did. It is not a functional language, but it does incorporate some functional principles as a part of the way it does things. It is a service-oriented language because, let's be blunt, most of the time when we are building systems, we are trying to build services that will often be accessible via some sort of external API endpoint. Much of the time it's HTTP, but sometimes it's actually a gRPC endpoint if we want to do something that's more binary, less intended for long haul. Or in some cases, it's because we want to consume messages off of, for example, a NAT server. So this is literally a reimagining of programming languages from a service-oriented perspective, which means that we want to make it easy to consume HTTP-based APIs. We want to make it easier to produce said APIs. That's the part that we'll be focusing on in this particular talk for the next 40 minutes or so. To parallelize well, because frankly, if you're going to produce services, services really should be able to run in parallel without a whole lot of concurrency between them, but without trying to be everything to all people. Frankly, if there is one criticism of the Java language and the C# language, is that they are really trying to do all things for all people. And that means you have a very, very powerful general purpose language, but in some cases it means that there are some potential shortcuts. There are some potential abstractions we could introduce into the language that would make it easier for a particular environment. Now, if you really wanted to try to build like a game in Ballerina, you probably could. Nobody's done it yet. You're trotting on virgin ground at that point. This is really a language that's designed to build service APIs and consume them. So, general purpose, concurrent, strongly typed. One of the things the Ballerina team, which is the WSO2 organization, they've actually been very, very involved in the web services community for quite a few years. One of the things that they actually had as a goal, I disagree with the WSO2 team on this particular point, and we've talked about it, so I'm not surprising anybody. The WSO2 team really focuses on the idea of there being a graphical syntax to go along with the textual syntax. Part of what they want the developer to be able to do is visualize the flow of control as you move through a service, as you move through various modules, etc. As a matter of fact, the Ballerina homepage, this is intended as a one-to-one representation between these two, which in of itself is a pretty interesting concept, because if I can take my text syntax and produce a graph out of it, then this can give people, particularly those who are not as strongly technical as your typical developer, this can give them a sense of how this code works without having to learn this particular syntax. Now, my personal belief is that developers will not author in this space. We'll continue to write code because for my years of working with different languages, this is still the most compact way to represent a series of concepts, particularly with some heavy flow control. This is pretty, and it often gives us a view, but this is not where I want to be authoring. This is where I want to be, and this is how I want to write code, et cetera, et cetera. But that is a design goal of the Ballerina language and the Ballerina team, is to be able to have both that graphical and that textual syntax. It is open source. GitHub.com/ballerinalang is the organization. They've got, as most open source orgs do, they've got the core repository, which has the Ballerina compiler. They've got a number of repositories with the various packages and so forth. But it is all open source. You can put issues in through GitHub. You can vote on things, et cetera, et cetera. And as a matter of fact, they just recently did their, let's see, they're currently, I think it's the Swan Lake release, the second revision of the Swan Lake release. Because the name of the language, all of the various major releases are named after ballets. So there's a Nutcracker back there. There's a Swan Lake. I don't know enough ballets to know what the next one might be, but, you know. Anyway, the key concepts inside the Ballerina language that you're going to need to know as we begin to look at some of the code. First of all, services are the principal distributed design choice. We want to build services. The end. That has been something that the industry has essentially voted on with 2 feet for the last decade, if not 2 decades. Going all the way back to the web services space, SOAP and WSDL and all that good stuff. We didn't like the syntax and the heaviness of those tools, but we loved the idea of being able to expose something that people could invoke, that programmers could invoke, over HTTP syntax. So we like the idea of services. And if anything, we've refined that concept a couple of times, going into the whole microservices space. Now people are starting to back away from that and talk more about macro services or monoliths or what have you. But the fundamental idea is we're still building services because that's the best way for 2 organizations to be able to integrate. It's how you can call into Twitter and post a tweet, although who knows, Elon may not allow that anymore. Who knows what's going to happen with that. It's what allows you, for example, to call APIs at your bank. It's what allows you, it's this whole services first concept. So make that a first-class citizen within the language and make that a concept that the language exposes and builds around very clearly. Concurrency should be easy/default. Observability should basically just be plumbing. If I want to know how my service is running inside of production, I, as a developer, shouldn't have to write a ton of code or create a ton of configuration to make that work. It should literally be a drop-in plugin. And that functions and explicit state are, in fact, sufficient for what we need to do. If you go to any object-oriented class, they will spend a significant amount of time talking to you about the fact that objects are a union of state and behavior, and we need to make the state private. That's why Java and C# and just about every other object-oriented language goes to great lengths to provide accessibility modifiers, right? Public and private and protected and so forth. And we create methods, or we have language constructs, properties, to keep that state in one place, because we really want to make sure that if we ever want to change the representation of this object, it'll all work and people won't have to change any of their code, encapsulation and yada, yada, yada. But when we start talking about state across services, there's a very clear distinction versus what's being passed into me through an HTTP API call and where exactly that state lives. We have actual process boundaries that help encapsulate all that state away. And so the idea of having to now deal with state on a micro level inside the process when nobody's going to be able to see it from the outside world really feels like it's just a bunch of additional busy work. So we can actually work pretty cleanly using functions and some explicit state. Now there are still times when it's nice for us working on the internals of the service to have objects. But that's not really the principal focus. Those are more implementation detail rather than the core focus of the language is around this idea of a service. I keep losing my headset here, so apologies if I keep fondling this thing as we go. One of the things that you're going to find, particularly if you come from an object background, real quick poll, how many people in this room program in Java? Show of hands. Anybody C#? Show of hands. Any JavaScript? Python? I think everybody, is anybody who's not risen their hand to one of those and you're not a cameraman or an AV person? What do you program in, sir? Swift, which is an object-oriented language. All right, fine. There's always one guy sitting in the back. Yeah. Anyway, they're all object-oriented languages, right? And this is not a language that's going to hold itself up as an object language. I've mentioned that. Now, one of the things that means is they approach the notion of type systems with objects in a very different way than most of the other languages, all of the other languages that I rattled off. They use what's called structural typing as opposed to nominative typing. Nominative typing, for those who aren't familiar with the term, is when I say that class student extends class person. Well, student is a person, right? That's the whole inheritance relationship polymorphism. We all learned that in 00101 way back in the day. But what if there is another class that happens to look exactly the same, has the exact same physical layout? Would that in fact be the same? Well, nominative typing, nominative meaning related to the name, says no, if you are not explicitly a student and if you are not explicitly inheriting from person, you are not one of these. JavaScript actually has some interesting scenarios where it will prefer structural typing, where it will say, you know what, if it looks like, if you've got a name and an age, and if you've got a place of residence, you're a person. Regardless of whether you have 2 legs or 4, you're a person. You're an entity in our system. You're a customer. Right? So structural typing looks at the actual contents of the object, the actual structure of the object, as opposed to the nominative, what does it say that it inherits from, what does it say that its name is. This is going to be one of those points that for a traditional object developer, this is going to blow your mind a little bit. Just as a heads up. We'll see an example of this as we go. Some of the core entities inside of a Ballerina program: a service, I've already gone on at great length about that. A resource is a single network accessible entry point within a service. So a service basically exposes a number of resources. Now this is a little bit different use of the term than what we're used to. This is actually hearkening back to the representational state transfer dissertation that Fielding wrote way back in the day. This is why technically when we are creating HTTP APIs, we are creating resource endpoints. And what they serve back is a resource representation. This is all the REST terminology coming to the fore here. So if you're not familiar with the term resource, think API entry point. This is going to be http://server.com/API/hello world. Okay? That's what Ballerina is going to call a resource. Isolation, can I run this code simultaneously in parallel? Is it isolated from other state manipulation going on inside of the service? And in some cases, we want to use transactions to be able to make state modifications knowing that they will either all succeed or all fail. And then Ballerina has this concept of what's called a strand. You're seeing a lot of different languages explore this idea of, I want to have a logical construct of execution, but I don't really want a thread. Because threads are heavyweight, and threads are an actual operating system construct, and threads can deadlock, and all this kinds of stuff. Ballerina calls them strands, and they promise that no 2 strands of the same thread will execute concurrently. This is a step that they take in order to try to prevent some of the common cases of deadlock that could wedge your service and force you to shut it down and restart. So how do I get started with Ballerina? Well, they've got a number of options. For starters, you don't have to do squat. You can actually go up to play.ballerina.io and play around with it in your browser. They do the usual new language thing where they have the browser, you can type stuff in, you can say compile, they'll ship it off to a service, it'll compile it, build it, run it on the back end, and then shoot the results back at you. So if you literally just want to explore this with 0 impact on your current machine, that's a good start. If you have Docker on your machine, because kind of today, what developer doesn't have Docker running somewhere? They have an image that you can pull it down and run it locally so that you can now drop inside a Docker image that has all the Ballerina bits installed and ready to go. You could also grab the source and build it yourself. Who's really excited to do that? Good, none of you. Not the best way to do it. Or my preference personally is to install it locally using a variety of options. My favorite is Homebrew. Homebrew works for both Mac OS and Linux. And by the way, if you're one of the Windows users in here, Homebrew, there's actually a Linux brew that will run on the Windows subsystem for Linux. So everybody can use brew install Ballerina, and it's all good. If you're not a big Homebrew fan, if you prefer raw package installers, feel free to grab one of the packaged installers that will put it in predefined places on your hard drive. Or you can just grab the zip file and explode it yourself, however you'd like. The thing is, Ballerina does run on top of the Java virtual machine. You will need some flavor of Java. And currently, they say they require Java 11 in order to run this. Frankly, the Java parts of Ballerina really are not visible unless you choose to make them visible. In other words, if you want to try to call something that's outside of Ballerina, then you'll see some Java-ness. But the rest of the time, Ballerina has done an excellent job in sort of hiding the underlying implementation, partly because the Ballerina team is also talking about doing a Ballerina native, where they will take your Ballerina code and compile it to actual native executable images using the LLVM toolchain. So they don't really want you thinking of this as a JVM language. They want you to think of it as its own creature. Drop Ballerina somewhere on your machine, put Ballerina bin into your path, and you will have the Bal tool, B-A-L, which is, like many languages, sort of your one-size command line interface tool. So Bal will give us a number of core commands: build, run, test, dock, and pack, as well as some package commands. Clean, we'll talk about some of these, particularly the Open API talk in just a second, right? If I want to update the tool, it's going to check to see what the current version is and fetch it, et cetera, et cetera. Once you have Bal on your machine, you really don't ever need to worry about using the additional package managers. You do a Bal update, it will fetch the latest version and pull it down. Personally, I just get into the habit of doing brew upgrade on my machine periodically. Ballerina gets updated as a result. I'm a happy camper. However you want to manage your machine, there are multiple ways to do that. But the Bal tool is how we get started, with all of this. Bal version 2201.2.2, Swan Lake, update 2. The language spec is 2022 revision 3. Yeah, this is the latest version as of 3-4 weeks ago. Okay. So now you have Ballerina. Where do you go to start learning the syntax? Ballerina actually has a ridiculously good amount of documentation. So Ballerina, by example here, is just a huge collection of one-pagers that talk about syntax. So hello world main, we'll actually explore this a little bit in my slides as well. But this is hello world in Ballerina. And it's a little scanty in terms of explaining what's going on here, but each code is runnable, and so you can either run this in the play Ballerina, copy, paste, go over there and run it, or pull it down, run it locally, and they'll show you the results, etc. Okay? This is a fantastic resource for learning the syntax. There's at least one book out that I'm aware of. There will probably be more when the language gains greater traction. For now, we're in that early stage where there's not going to be just one place where you can go and consume all of your Ballerina-related questions. If you are of a sort like me and you like reading such things, the Ballerina language spec is available. And, if you really want to explore all the various nooks and crannies of the language and look at the syntax. All right, if you wanted to create a new package in the Ballerina syntax, a package is basically going to be a module, could be a collection of modules, but particularly if we want to do the thing that we always do for every new language, that is to do the hello world, Bal new greeter will create a new package, Ballerina package. It'll create a subdirectory called greeter, and it'll put a couple of different files in there. As a matter of fact, let's create a Bal demo. Oops. So Bal new greeter, like so. You can see there's a subdirectory there called greeter. Let me pull this up so it's a little bit easier for people in the back to see. If we go inside of greeter, we can see there are two files. Main.bal Ballerina syntax ends in .bal, in case you didn't pick that up from the earlier Learn Ballerina slide. But there's also a toml file. This is your main configuration file for Ballerina. And we will occasionally go do things inside of there, such as, for example, if we want to change the org, who created this, what is the name of this package, what is its current version, what is the version of Ballerina that this was built with. Okay, so we can pin to a particular version of Ballerina as we desire. We can also indicate through various build options whether or not, for example, observability will be included. Now, this is a hello world. We're not going to observe much. I mean, frankly, if this were a running service, we would want to have a dashboard. We would want to see all the lovely numbers of requests coming in, requests going out, how many people were getting which resource endpoints, et cetera, et cetera. So this is probably overkill here. But one of the interesting things that Ballerina will do, and again, really it's just setting the right settings inside of Ballerina toml. We'll see this in a second. I can compile Ballerina to a Docker image. This is the first programming language that will actually take me all the way from source code to Docker image ready to be deployed in your cloud of choice. That's huge to me, because now I'm actually working with a language that, again, it wants to embrace the idea of services first. And what do we always do with services? We bundle them into Docker. We combine those Docker images into a Compose or a Kubernetes, and then we put that into the cloud because that's what we do. And so Ballerina is going to actually short circuit some of the steps. I don't have to maintain a Docker file by hand anymore, for example. Ballerina will do all of that for me, and the result will be a running Docker image. And that's where some of the org and the names will be more critical, because that will be some of the names they queue off of for creating some of the Docker image. But I'm getting ahead of myself, right? So I've created the package, and if we look at the syntax inside of this guy, so main.bal, this is again what we saw earlier. Yeah, go away. So a couple of things, right? First of all, well, let's make this interactive. What do you notice about this code? Throw your meat stick into the air and I will call on you. It's just like in grade school. In the back, sir. It's kind of like Java. It is kind of like Java. Why do they do that? Because programmers come from someplace, and many programmers come from Java. Many programmers come from C#, so there's a certain amount of C#iness to this here as well, because both of those languages are essentially a C family language, which tells you several things. There will be curly braces. There will be semicolons, right? There will be arguments over where the curly brackets will go, because that's just what we do as programmers. Ballerina style says to do it Java style with the curly bracket at the end of the line. But it's designed to be something that's approachable to the developer who is coming from one of these other popular object-oriented programming languages. Even the Swift guy could take a stab at what this is saying, right? Right, Swift guy? No, shut up. Shut up. What else do you notice about this code? The class name is missing. Yes, because what good would a class do in this case? Nothing at all. Think about your classic Java hello world and how many characters you have to go through before you get to anything of any substance, right? Public, what is this for? I mean, think about teaching Java to somebody who's never programmed before, and they look at your classic Java hello world. Public, what does this do? Never mind, you don't care. Class, what does this do? Never mind, you don't care. Hello world, what does this do? Never mind, you don't care. Curly bracket, what does this do? Never mind, you don't care. We haven't even gotten to main yet. And then you go public static void main, and it just has to be that name. There's so much cruft, so much ceremony that goes on when you have a language that insists that everything must be a class. Ballerina says, screw that, let's get to the good stuff. Yes, main entry point. Public, yes, because we want this to be accessible from outside this module boundary. It's a function, io::println, and we're off and running. Now we're ready to say hello world. We're ready to greet the world, right? This is, again, reinforcing the idea that Ballerina is not an object-oriented language. It supports objects. It's a supportive language. If you want to think in objects, you can continue to do so. But fundamentally, this is a service-oriented language, and it wants you to start understanding that services are actually kind of a lot like procedures. You remember that from way back when? Maybe I'm the only one old enough to remember languages like C and Pascal. Anybody here ever heard of Pascal? A couple of hands. Okay. How many people have actually laid their hands on a floppy disk? Oh, wow, this is the old-timer crowd. This is awesome. I feel like I've come home. This is great. I teach at a university in Seattle, and I ask that question to my classes, and most of the time the question is, what's a floppy disk? And I'm like, oh, God, kill me now. Anyway, so this is our source code, okay? And now there's a couple of things we can do with it. One is we can actually build it, and this will actually, under the hood, turn this into a Java jar file suitable for execution. So if you are a Java developer and you want to take this jar file along with the Ballerina supporting code and run it, yeah, you can do so. See there in target bin greeter.jar, you can see that we now have a target directory as well as a dependencies.toml that tracks the dependencies for this particular project. We can also just say run it, and it will build it for us if it hasn't already been built. And hello world, yay, we are now all officially Ballerina programmers. See, build stuff gives you more. You came in here, your resume was stark, it was barren, it was missing something, and now you have it. You can put Ballerina programmer on your resume. You're welcome. You all really should be laughing harder at that, but maybe some of you do practice RDD. You know what that is, right? Resume-driven development. Anyway. So this is how we can execute the code. Knowing that it's a jar file, we can also target bin greeter.jar. I haven't actually done this. Oops. CD target. CD. Oh, that's interesting. Did they stick it in cache? Yeah, it's buried way down there. Again, there it is. We really, really want to hide some of the Java-ness away from you so that you don't have to, because frankly, if I talk about Ballerina to a group of .NET developers, as soon as they see jar file, they're like, that's it, I'm out. I don't know what a jar file is. All I know is that pickles come in jars, and I don't want pickles in my programming. I actually had a guy tell me that once. I hate jar files. Why? Because they remind me of pickles, and I hate pickles. What? Anyway. So, easiest way, of course, is to just do a bal run. There's, whoops, helps if I'm in the right directory. There we go. Now, you'll notice a couple of things. First of all, the Ballerina compiler is not the world's fastest creature, okay? There is a lot of optimization work that the Ballerina team has to do with respect to the compiler. But fortunately, they already have identified a number of steps that they know they're going to take in order to improve the compiler performance. So we can expect that that will continue to get better with every successive release. The other thing is, quite frankly, hello world is kind of boring. I mean, let's just call that spade a spade. So slides here kind of walk through the same amount of stuff, right? Runs on top of the runtime, bal run, bal build here. And I think because I did the run after the build, I think that's why it removed it. Sir?
Yeah, if you go some slides back, you can say something. Yeah, heavy FD flags.
Yes. Well, because they expose functions, right? One of the things that they really want to bring over, I mean, believe me, these guys are not unaware of all the various enhancements that have been made to various programming languages over the years, right? Just like the Swift creators brought a number of functional concepts into the language, the Ballerina folks did as well. And so where it makes sense, they absolutely want to leverage, the idea of being able to pass functions as first-class values, to be able to create higher order methods on top of collections, for example, to be able to walk through a collection by passing a function saying, here, filter out based on this, lambda predicate. They put all of that stuff into the language. So they've pulled in the functional idea, particularly the idea that in a well-written functional code, right, if I have a well-written function, I'm not modifying global state. And that intrinsically leads us to better immutability, better concurrency, better, et cetera, et cetera. Right? So yes, they were influenced by functional programming. That does not mean that I would classify Ballerina as a functional language, because there are certain concepts of a functional language that are not present in Ballerina. For example, immutability by default. There are a number of places where Ballerina will let you declare something to be immutable, but that's not the default, right? And like being able to do things like currying and partial application of functions. That's not as critical in a service-oriented language. So they made some very deliberate design choices as to how much functional they wanted to pull over. You will never hear a Ballerina programmer talking about monads, for example, for which I am profoundly grateful. So, all right. So build, run, etc. We've looked at both of those. There's also a test. There is a test package. There is a way of dropping some tests in. We'll see that when we look at some of the code. But let's talk about what is a more proper hello world for Ballerina, which is to say a hello world that runs as a service. Now I want you to think for a second, in your programming language of choice, how long would it take you to create an HTTP API that's exposed over port 8080 that responds to a /greeting request, taking a parameterized name here and returning either hello world or hello name, plus making it service accessible, plus putting it into the Docker image so it can run in the cloud. That's it. What we see here, first of all, we see the import statement saying we're referencing the Ballerina HTTP package, module to be more precise. That will give us access to HTTP listeners, where in this case we are saying I want a new HTTP listener on port 8080. And specifically I want to expose a service that has no prefix to it on that particular listener. And I have one resource called greeting. So this name and this are going to combine to create that particular endpoint, that particular resource endpoint. And there is another option here where they could pass a string name, in which case I just access it as a parameter, the end. Oh, and you'll notice that the HTTP verb is actually a part of the resource definition. So if, for example, I were to misspell it and use GTE instead of GET, or if I were to want to change this from get to post or put, it's actually a part of the resource definition and the compiler can check it. Okay? So this is Ballerina Hello World API style, RESTful style. Okay? And I guarantee you that pretty much for any language, one file, I mean two if you count the ballerina.toml file that we looked at earlier, but that's going to be pretty straightforward. And again, to run this thing, balrun, so that's going to be the tail end of your Docker image, right? That's the last command to have the Docker image once it's loaded and run in a container. It's now listening on port 8080 and able to process requests via your classic curl HTTP client. Sir? I don't quite understand your question. Is it possible to do what? Oh, I see what you're saying. So what you're calling REPL-driven development, where I'm interactively, there is a REPL for Ballerina. So you can certainly type all of this into the REPL as you go. I don't know if it will go all the way to get where you're talking about, where you are using the REPL as your first class development environment, and so you can take an entire REPL session and save that off as a .py file so that we could run it again later. I don't know that Ballerina can go there. It could be something that, if the Ballerina team sees enough interest in doing it that way, there's nothing that stops them, right? But that's not I don't think that's really their principal focus, right? Because Ballerina, the lines between interpreted and compiled are so blurry these days anyway. You know, you have a Java REPL now, which just compiles code into bytecode on the fly. Python as an interpreter has always compiled its source into a bytecode and then executed it on the fly. So interpreted, compiled, it's really kind of blurry. So there's no reason Ballerina couldn't do that. I just don't know if that's on their radar. Yep. So now if I want to actually take this and turn it into a Docker image, I literally will just add the build options cloud equals Docker to that TOML file. I then must also add a cloud.toml file. So now we're up to 2 files, 2 of which are configuration. We're still one source file. And specifically, do I want to build the actual Docker image, in which case it will pull all of the dependencies down and it will generate the image and it will now live on your machine suitable for uploading into whatever Docker host you care to name. Or you can say, don't actually build the image because I want that to be done as part of my CI/CD process, because it actually takes a while to do this, to create the Docker image. So you may set it to false. That will generate the Docker file, which you can then run the Docker build in some later part of your process. Either way, when you do a bal build, it will go through, compile your Ballerina, and either generate the image or generate the Docker file so that you can generate the image later. Like so. Okay? Then once you've got the Docker image, you run it using a standard Docker command, in this case mapping port 8080 in the image to 8080 on my local machine, so that I can then do the curl for my local machine, and it all just works. Okay. So one of the things that I wanted to do when I started playing around with Ballerina is I wanted to attack something that was not Hello World, because frankly anybody and their brother can do a Hello World. I have actually seen a Hello World HTTP service written in x86 assembly language. It was not pretty, but it worked. So really where Ballerina is going to get a lot of its majesty is going to come from when it's trying to attack a problem that is not trivial. And Hello World is certainly trivial. So I said, what's a relatively small project that is something that, you know, a service could conceivably implement? And tic-tac-toe. Let's build a simple tic-tac-toe game server. No AI. I'm not trying to get into the AI machine learning thing. But just so that 2 people could connect up to a service, identify a particular game, and trade moves back and forth. And the server will implement the rules. So that if the players try to play out of order, you could imagine somebody building a React front end for this. As a matter of fact, I'm pretty sure there's some React tutorials that build a tic-tac-toe graph. So take React, wire it up to my service. We're all happy. More importantly, it's actually a bit of a non-trivial problem, particularly because what I wanted to do with this is I actually wanted to start from what we used to refer to as contract-first programming. In other words, I want to work from a tic-tac-toe open API description, right? Because Ballerina will let you create services and then generate an open API, what used to be called Swagger. It'll let you generate that from your running service. But generally speaking, we find for longer survivability, it's better if we kind of define our IDL first and then generate the Ballerina service code from there. So that was the direction I started with this. And I also wanted to kind of mimic the traditional sort of box arrow, cylinder kind of application. So the HTTP endpoints will call into a business layer, which does a certain amount of validation of the call, and then we'll pass the results into a persistence layer, which then stores to a database. And because this is Java, I chose to use the H2 embedded database because basically it just stores it to file. It's the Java equivalent of SQLite. So that gives me a really, really simple persistence layer, but it's still a relational database, and people still have to do the relational things with it. So hopping over here, this is my service, and fundamentally, I think this is, yeah. So my TTT YAML file here, this is a tic-tac-toe YAML that actually I did not create myself. I Googled tic-tac-toe OpenAPI spec and found one, because I actually really, really wanted to assume that I didn't have complete control over this thing. So this describes a series of HTTP endpoints, slash games, slash get will give me a list of all the games running on the server, slash post to create a new game with some required information like the names of player 1 and player 2, right? The various responses that are possible to retrieve a particular game by identifier with a JSON representation of the tic-tac-toe board, et cetera, et cetera. So this YAML file contains a collection of endpoints as well as a collection of types. So here is my schema for a game. It has an ID, the 2 players, the board itself, and a message. What just happened most recently? Player X moved to square 5 or something like that. Okay. So I run the Ballerina OpenAPI generate tool to get a mock service, and it gives me something similar to this Ballerina service file. Let me close this. So we can see there's a number of imports here, HTTP. You can see a function init. This is a hook for the module as a whole to let me know when this is fired up. This is mostly for diagnostics purposes as I'm debugging code to make sure that I got the modules named correctly. But if there's any particular initialization that I need to do, this is a good place to do it. You can think of this module initializer very much the same way you think of an object constructor, but this is module-wide as opposed to object-wide. I set up my listener on port 9090. I then have a service running on EP0. And you'll notice, first of all, that this resource function is isolated. This is a keyword inside of Ballerina that then uses compiler enforcement to ensure that my code is not doing anything that would potentially conflict with other things running in parallel. This is tricky. I had to spend a non-trivial amount of time, and in some cases I had to ask the Ballerina team for help to get my function to in fact be properly isolated. It is not the easiest thing in the world to do, which is actually a good thing, because the compiler refuses to compile unless the code is in fact isolated, which is what I want. I don't want to have to debug concurrency problems at runtime. I want the compiler to do that for me. And so here, I've got a function called getGames, which goes into the persistence layer to grab games. If games is an error, in other words, if this, for whatever reason, doesn't come back correctly, and you'll notice there's a very interesting little bit of syntax going on here. I'm either going to get a game array, or I'm going to get an error. This is what's sometimes referred to as an intersection type. It's saying that this games will be either one of these types. If it's an error, well then let me return an empty array so the user doesn't see that we had some kind of problem. Otherwise, let me just return the games array. Notice it returns game array. That will silently transform into JSON automatically. Oh, Ballerina does support pattern matching, most definitely, right? And it's a very rich set of pattern matching. Right, much richer than what the Java switch statement has given us more recently, right? We can switch on types, we can switch on values inside of a tuple, et cetera, et cetera. It's really nice. I don't think I use. Do I use any pattern matching in here? I don't. I probably should. This is a decent place where I could use some pattern matching, but it was easier to reason it out at the time using if-else. I mean, this was something of a learning exercise for me too. So in the back. So Python multiple outputs are generally a tuple, and Ballerina does support tuples. And so if I said I really want to get multiple return values, if I'm returning from a function here, I would have to describe the tuple in some way so that the consumer understood that they're getting one of several different types of JSON back, right? But if it's internal, I mean, I can just describe the tuple type using a type keyword, right? But if I find that I'm using the same tuple type repeatedly, it may actually make sense to turn that into a more formal structure, right? This, however, the fact that I can get either a possibility of a game or an error, this will actually eliminate a lot of the common need for those kinds of multiple return types, right? Because frequently I want to know, do I get results or was there an error? So Python will return that as a tuple where one is empty and the other is full. Here I'm saying it's either or. So it can serve some of the same purpose. It's not a complete overlap on the Venn diagram, but it does answer some of the common problems for Python. Let's see, what else that's interesting down here? The question mark indicates that it's nullable, right? Because when I'm trying to find a particular game by ID, remember, it's possible for somebody to plug in just a random set of numbers that may not correspond to a game ID. So I have to deal with the possibility that there is no game by this particular identifier, in which case, it's not an error, it's just there's no game. So this is a nullable modifier for the game object. Well, so the language has some opinions about when nulls can be used, and they can be used when you explicitly specify nullability. So it allows nulls, but it's not null by default, right? Because C# and Java both are like, oh yeah, sure, return a null, whatever, we're okay with that, right? So again, this is kind of some of that functional influence coming back over to say, yeah, nulls, you know, the guy who invented null has since apologized. Did you know that? Sir Tony Hoare, who was knighted by the Queen for his contributions to computer science, has since gone back and said, null was my $1 million mistake. And frankly, I think he's letting himself off easy. Based on just the number of null pointer exceptions I've gotten in my life and my bill rate, it's probably more like $1 billion mistake. But let's see. So notice here, return HTTP not found. This is the actual HTTP status code. And so here we are returning a JSON object specifically that will contain the not found type, which was described out of the YAML code. Let's look, by the way, at my functions. This is my business layer. Remember, I had this very explicit segregation. So this first layer was just let me take in the inputs and decide where to go. This is a collection of functions. So here, for example, this is that getGames function that I talked about earlier. And you'll notice that it returns either a game array or an error. And you'll notice that I just call into this thing called gamedb.retrieve. GameDB is basically my table data gateway, to use the pattern terminology from Fowler. But notice a couple of things. First of all, this syntax here, that is Ballerina doc. So there is a documentation tool that will produce Ballerina themed documentation. So here I'm saying this is my function name, these are the return types, etc. Notice also the check keyword. This is what will decide whether or not this is correct or whether it returns an error. This is intended to be a replacement for exception handling. Yes? You're on in 5 minutes? Oh, damn. Okay. Well, thank you for telling me, because I thought I had 5 more minutes. Let's see. The last thing I want to show you very quickly is the actual persistence layer here. So a couple of things. First of all, notice these two values are described as configurable. This means that by default they will have these values, but they also will be looked for and pulled up at runtime from the configuration file, ballerina.toml. Remember that? You can see that the class is isolated, and we have a series of methods here that essentially do standard SQL type stuff. This is not an object relational mapper. Ballerina does not have an ORM because, frankly, I don't need it. I'm not trying to map objects to relational. I'm just trying to take data and store it into a relational database. This is all using standard Java JDBC type API calls. And much of this is just straight up SQL with some interpolation, so it's relatively straightforward to understand. Question? Knowing that I only have like 1 more minute. Quick question.
What if you want to use an SDK from Java because it's Ballerina?
Yes, and so flipping through slides very, very quickly, there is a foreign function interface, like so, right? So here I can write some Ballerina code that says I want to map the return of this function to this particular field on this particular class, or I want to be able to invoke this particular method on this particular class with these particular parameters. So there is a foreign function interface to anything Java. Maybe a little unwieldy to write all of these for your SDK, but it's still accessible. Okay? Ballerina's cool. Try it out. Peace out.